guys, in previous video we have seen the theoretical portion of lever, what is the concept and what are the various applications and what are the various types of levers that we have seen. Now in this video we are going to see the design procedure of a hand lever. Okay, please see, please listen carefully. Design procedure of a hand lever. Okay, how hand lever is designed. So in this image you can get to see hand lever, that is various. Let us see first what are the various parts of hand lever. That is, you can see this boss, then bearing, and what are the various you know L is the length of your uh, hand lever, W is the load which is to be lift, and this is what this is dimension of your load arm, that is 25 mm. Okay, B, D by 2, T by 2, all these are we are going to see. This is D1 means what, R2 is there is 0.8 times of D is given, what it means 16 mm. Then what do you mean by is T, T2, L2, D2 and D, we are going to see it in detail in next slide. So this is the diagram of your hand lever. Now please see what are the various notations, all that we have seen here, B, B, T, what it means, please see. These are the notations of your hand lever. So P is equals to your force applied at the handle. See guys, force applied at the handle. Then capital L is your effective length of lever. Capital L is your effective length of lever. Small d is diameter of shaft. Small d1 denotes diameter of shaft at the center of bearing. Then d2 denotes diameter of boss. L2 denotes length of boss. L1 denotes length of key, and small l denotes overhang distance of bearing from the lever. So all these are the notations which plays very important role while designing hand lever. Okay, so please see what next. Now step number one, please see guys, what is the step number one of designing lever, please see, sorry, designing hand lever. Okay, considering shaft is under pure torsion, we have, first of all we need to consider shaft under pure torsion while designing the hand lever. This is the first step. So how it is given, T is equals to pi by 16 into tau into d cube. This tau is for shear stress. Okay, pi by 16 into tau into d cube, but twisting moment on shaft is T is equals to P into L. So on equating we have, this we just put this value of T in this formula, then what we get, please see, P into L, that is for T, is equals to pi by 16 into tau into d cube. So by this relation, diameter of shaft D may be obtained. Okay, by equating this P into L with this pi by 16 into tau into d cube, we are getting diameter of shaft D. Okay, so by first step of uh, design of hand lever, we get this diameter of shaft D. Okay, next is, this is step number two. In this step number two, we need to use some empirical relations for fixing some dimensions regarding to hand lever. See guys, using the empirical relations, fix the other dimensions like d2 is equals to 1.6 times d. D2 is equals to what? 1.6 times d. T2 is equals to 0.3 times d. L2 is equals to d into 1.25 times d. Small l is equals to twice of L2. Small l is equals to twice of L2. So all these are the various empirical relations that we need to fix. Then next is, this is step number three. This step number three, what says, please see. Considering the shaft supported at the center of the bearing. See guys, considering the shaft supported at the center of the bearings under combined twisting and bending moment. See guys, we need to consider the shaft supported at the center of the bearings, which we consider under combined twisting and bending moment. Combined twisting and bending moment. Then we have capital M is equals to P into small l, and capital T is equals to P into capital L. Now equivalent twisting moment is equals to Te is equals to under root of capital M square plus T square. So we need to put this value of M and T here. Under root of P into L square, M, value of M is P into L. Please see, the value of M is given here, P into L. So I just put the value of M, P into L square, and value of T is P into L. So I have put the value of T is here, P into L. So P is common here. So I have P, take it out of that under root. So under, if I take P as a common, then what we left with? We left with under root of L square, small l square plus capital L square. Also equivalent twisting moment Te is equals to pi by 16 into tau max into d1 cube. So I have just put here value of Te is P of P into under root of L square minus L square, small l square minus, sorry, small l square plus capital L square, sorry, P into under root of L, small l square plus capital L square is equals to pi by 16 into tau max into d1 cube. Okay, so from this equation we can easily find out the value of d1. Okay, and you can see as small l is equals to twice into L2. Okay, the value of small l is twice of L2. So let us see what it is. So from here we can easily find out the value of d1. Okay, now step number 4 is design of key. See guys, design of key. Let t1 is equal to thickness of key. What small t1 is equals to thickness of key. Capital W is equals to width of key, and small l1 is equals to length of key. After finding diameter of shaft D, see guys, after finding diameter of shaft D, we can fix the dimensions for key as, we can fix the dimensions of key as capital W is equals to small d by 4 and T1 is equals to d by 6. Okay, small d by 6. Considering shear failure of key, we have capital T is equals to W into L1 into tau into d by 2. See guys, W into L1 into tau into d by 2. Length L1 can be determined. By this relation, length L1 can be determined. So length L1 may be taken as length of boss, that is L2. See guys, length L1 may be taken as what? Length of boss, that is L2. So L1 we need to consider as L2. Okay, L1 is equals to L2. By this relation we can take. Now please see guys, step number 5 is considering the bending failure of a lever, we can determine the cross section of the lever near the boss. So let T is the thickness of lever near the boss, and capital B is equals to width of height of lever near the boss. We have bending moment on the other lever, that is M is equals to P into L, and section modulus is equals to Z, which is equals to 1 by 6 into T into B square. So bending stress sigma B is equals to capital M by capital Z. So we've just put the values of this M and Z over here. So sigma B is equals to value of M is P into L, I have put there, and value of Z is 1 by 6 into T into B square, I have put here. You can see. So this is M, this is Z. Width of lever may be taken as B is equals to 4T to 5T. Okay. So we can easily find out this, and with these 5 steps we have completed our design procedure of hand lever.